This is exercise 9F, continued, tangents and normals. This morning we looked at question 13A, where the tangents at P and Q intersected at point R. So I'm just going to do a quick sketch of what that would have been. So tangent at P and tangent at Q intersects at R. That's what today's 13A was. You had to find the equation of the tangent at P, and you had to find the equation of the tangent at Q, and you had to find the point of intersection R, which we did work out. In part B, you had to find the equation of the normal at P. Now, if this is the point P, which is 2AP AP squared, the tangent goes like that in the dotted line, which you can barely see, but the normal goes up like that. So that's the normal at P, that one. All right, in blue, I've got the tangent at P. Now, and then I'll do the normal at Q. So in part B, you did the equation of the normals at Q and P. Now, I'm not sure exactly what the points are, but these are the normals at Q and P, and we showed that they intersected at point U. Okay? That's what we've done so far today. Now, part C of the question says, if PQ is a focal chord, show that the interval, running off paper. So it says, part C says, if PQ is a focal chord, show that the interval RU is parallel to the axis of the parabola. Now, I've done a very quick sketch where U is, up there, and down here I did a quick sketch where R is, somewhere down here. We're hoping that RU will be a straight line down like that. Now, if RU is a straight line down like that, it would have equation of the form, what? X. Now, it's passing through the x-axis. We're expecting x equals something. That's it. And y is 0, and y is 0, well, we'll see. Okay. Yeah, that's what we'd be expecting, that the equation, that we'd be expecting x is just something straight down. All right, if PQ is a focal chord, what do you think we should be doing? They're talking about PQ. Now, I'm going to join PQ. If PQ is a focal chord, what does a focal chord do? Let me sketch. All right, and when we did all those focal chord questions last exercise, what did I have to do? Girls, you're going to have to, you don't want to do it. You have to find the equation of PQ, not the distance, the equation of PQ, and because it's a focal chord, it passes through 0A. So what you've got to do for part C, it doesn't tell you to do it, but hopefully in a HSC question they will. But if PQ is a focal chord, in other words, it passes through the focus, show that the interval RU is parallel to the axis. Don't worry about that yet, let's just work with PQ. They don't want the distance PQ, they want the equation of PQ. Do you know how to do the equation of PQ? It's what we did last lesson. Point gradient formula. First you need the gradient of PQ. So if you want the equation of a line, find the gradient of the line and then the equation of the line. When we're finding the equation of tangent, when you differentiate, that's finding the gradient of the tangent, and then you use point gradient formula. So always, equation of chord, equation of line, we want the gradient and a point. So our gradient here, the gradient of PQ, do we know what to do? Wouldn't it be y2 minus y1? Why don't you try and do that, girls? Do you know what to do? Gradient of PQ. So let's go. y2, x2. I love doing the p's minus the q's. I don't like doing q minus p's. So it's always p minus q for me. So y2 minus y1 is going to be what? Do you want to just do it on your own? Squared minus aq squared over minus 2aq. What do we do next? Take out the a's and you'll get p squared minus q squared. And if you want to be really nifty, you can take out the a and factorise the p squared minus q squared in one go, but you don't have to. When you get proficient, you can do it in one go. 2a bracket, p minus q. This now tells us maybe we should do some factorising. A. The A is going to cancel, but I'll leave it there. What do we do now? Minus Q, P plus Q over 2A, P minus Q. Now we do our cancelling. P minus Q's go, and an A. So it's P plus Q on. Now you should be familiar with that. Tangent of the chord, PQ is always P plus Q on 2 or a half times P plus Q. Now we want the equation of PQ. I'll just do that over here. So the equation of not focal chord, just a chord PQ. First you find the equation of the chord PQ, then you deal with the fact that it passes through the focus next. So equation is point gradient formula. So girls, in this whole topic, equation of a tangent, equation of a line, point gradient formula 100% of the time. Got it? Not 2-point formula, we don't do that. All right, point gradient formula, that's it. But there are two ways of finding the gradient. Here you use gradient formula. For tangents, you differentiate to find the gradient of a tangent. All right? So y minus y1 equals mx minus x1. So the only new thing with this topic is all the 2AP, AP squareds. Everything else is done the same way, same process as what you've learnt before. So what do we got? Y minus, we like to use point P, please, no point Q. I like point P. I want the gradient and point P. So I'm going to use the gradients P plus Q on 2, and the point, let's use point P. All right, Y minus equals P plus Q on 2, X minus 2AP. Now, I'd really like to get rid of that, I'd get rid of, unless you want half sticking around, but I'd probably put that 2 over the other side. It doesn't have to be y equals with these. So let's put that 2 there, 2 bracket y minus AP squared equals. Now you're left with P plus Q, all of that times the X minus 2AP. You're okay with that? It's not just the Q times the bracket, it's all of that. That's P plus Q, has to stay together. So I just removed this divide by 2 and made it times 2 on the other side. So let's expand. What do we got? 2y minus 2AP squared equals px minus 2AP squared plus xq, or qx, minus 2apq. Now, if you're just looking at it, these cancel, because if you take the minus 2AP squared to the other side, you get plus 2AP squared and they go. It's easier just to cancel there now, and you've got that 2y equals, px. Oh, why don't we, if you want, girls, you could, x is a common factor here. What have you got? P plus q minus 2apq. Look, you can then divide through by 2, but I'm just going to keep it. It doesn't say show that it's this or whatever. Just going to keep it like that. Now, that's the equation of chord PQ. Then we say, but PQ is a focal chord, so that means, therefore, it passes through. If it's a focal chord, it passes through what? Yeah, this is your traditional parabola, x equals 2at, y equals at squared. It passes through the focus. So what are you going to do? When a point lies on the line, you substitute it into the line. So you're going to substitute x is 0, y is a into that. So you get 2 times a is 0 times all of that. It's gone. 0 minus 2apq. Right. I've got 2a equals minus 2apq. What do you think we do? Let's keep PQ here. What are we doing with this? I'm dividing by negative 2a. Can you see that? 2a over negative 2. It's not, you're not picking up the minus 2a and taking it over. No. What I've got 2a is minus 2a times PQ. That's a times between those. So what you're really doing is dividing both sides by negative 2a. That's what you're really doing. Now the negative 2a's cancel, and you got PQ is negative 1. Now girls, this is another result that you will see over and over again. Whenever you've got a focal chord the relationship between P and Q is that P times Q is -1. You're going to see it over and over in HSC questions. If PQ is a focal chord, show that PQ is -1. Now, it didn't say to show that, but they've just told us PQ is a focal chord. There's nothing else you can do but find the equation of PQ. It's a focal chord. Substitute that in. So now what we've got, we have to show that RU is parallel to the axis. So, all right, girls, if R and U are on top of each other, let's just see what R and U are, okay? I've got that. I'm just going to stop. I'm going to write down what R is here. Actually, we can probably already see it. Let's see what R is. What's R? It's, girls, if R and U are above each other, shouldn't they have the same X value? That's what R is. And U is, I'm going to put it underneath. So, if RU is parallel, so that's what R is, that's what U is, and from the page before we know that PQ is -1. That's what we've done so far. So we know the coordinates of R, we know the coordinates of U. Geez, they're almost the same except for this PQ being here, but we've just worked out that PQ is -1. What happens when you put PQ is -1 here? You get positive A bracket P plus Q, which is the same as that. Girls, when 2 points line a vertical line, their X values are the same. Like if I've got 2 points here on a vertical line, they're both X is something, the same thing, Y is something different. Do you get that? All right, so if RU is parallel to the axis of the parabola, then the X values or coordinates of R and U must be the same. Or are the same. Well, let's just see. Let's see what U is. So U happens to be this. What are you going to do with that? Why don't we sub PQ equals -1 into the U point? Does that make sense? What do you think, girls? Do you think we should do that? Oh, here, I'm off the page. So, if they're saying show that RU is parallel to the axis of the parabola, we're saying, well, if RU is parallel to the axis of the parabola, it's a vertical line. It is vertical. It is a vertical line. It must be a vertical line. And so thus, or therefore, the X values of R and U must be the same for them to be on top of each other, on the same vertical line. See, like, how do you get there? X up, Y up, X across, Y up, X across, Y down. But the X across is the same. So what am I going to do? I'm going to put PQ is -1 in there. So what do I get? Negative A times -1 bracket P plus Q. A bracket P squared plus Q squared. What should I do with this PQ? -1 plus 2. I mean, you don't actually need to look at the Y value, but I will anyway. So what's this? Negative A times -1. A bracket P plus Q. Isn't that the same as the X value for the R? It is. Comma, A P squared plus Q squared plus 1. Now, if we sub, we don't have to, but, and R is the point A, I'll just go U is. R is the point A bracket P plus Q, A PQ, which is what? What's A times PQ? A times -1. Which means R is the point A bracket P plus Q, -A. Because PQ, if you go up here and look at what R is, it's A times PQ. So anyway, now that we know that R is that, tell me where R lies on its Y value is -A down here. Lies on the what? Directrix. You know how if this is X squared equals 4AY, and it is, isn't the focus just an extra bit I thought I'd throw in. Isn't the focus of the parabola 0a? Isn't the directrix y equals minus a? So another question they could ask you is show that R lies on the directrix. All right, the question just says, if PQ is a focal chord, show that RU is parallel to the axis of the parabola. Now, if it's parallel to the axis of the parabola, RU has to go straight up and down. Well, if 2 points have the same x value, like if you plot the point 2, 5 and the point 2, negative 1, aren't they in a vertical line? Look, if I plot the point 2, 5 up here and the point 2, negative 1, do they lie in a vertical line? No, the x values are the same. It's negative a times negative 1 is positive a. The x value for R is a bracket p plus q, the x value, that's the y value. Doesn't matter. U just happens to be down here. We just want the x values to be the same. They're not the same point. They're above each other. So if I have to plot R, I go across a bracket p plus q and I go, sorry. Oh, I know what you're saying. Thank you. Oh, wait. Got it. This is R. Thank you. This is U. There you go. Got it. R is A P plus Q minus A. That's R. I just labelled it wrong on the diagram. U is up there. U's positive. If I look back here, look. R is down here. I made a mistake. U's up there. It does, because when you substitute PQ is negative 1, you know how we just worked out that PQ was negative 1? You get negative A here, which is what I've just done here. So we've substituted PQ is negative 1 into U and R. It doesn't matter about the Y values for it to be a vertical line. It just depends on the X values. But do you get that now? What I had was these points for U and R and U. All I did was substitute PQ is negative 1 into both of them. And when I did that, I got that U is A bracket P plus Q, A bracket P squared plus Q squared plus 1. Now that would definitely be positive. So U is up there. When I substituted PQ is negative 1 into R, I got A bracket P plus Q, and APQ became A times negative 1, which was negative A. So we're just making the observation that R lies on the directrix, because anything with a Y value of A of negative A lies on the directrix. Because the directrix is Y equals negative A. So any point that has some X value and Y value negative A lies on the directrix. No, that was extra. I just did that extra just to point that out. You could be asked a question like that as well.
So again, how we find the
gradient of PQ, is that? Gradient of PQ, because it's not a chord, because it's a chord, it's just like gradient of a straight line. Y2 minus Y1 over X2 minus X1. It's only when it's gradient of tangent do you do the derivative. Do you remember all the work we did on gradients of tangents and I was sliding things along curves? For the gradient of the tangent, you do the derivative. If I want the gradient of PQ, it's just a straight line. It's just gradient of a straight line, Y2 minus Y1 over X2 minus X1.
Why do we do that?
Because we're told that PQ is a focal chord. So if it's a focal chord, find the equation of it. Look, hopefully they would ask you to find the equation of it. Do you know what I mean? I mean, if they're telling us PQ is a focal chord, show that RU is parallel to the axis. At the moment, we've just got R and U, and we don't know, they're not the same. So R and U have slightly different, they appear to have different X values. If we work out that PQ is negative 1, then R and U will have the same X values. See, this was the answer from part A. And this is the answer to part B. And they're saying show that R and U form a vertical line. Now, unless I can work out what PQ is, I can't show that. So the only way you get PQ is -1 is if PQ is a focal chord. Now, that's why they're saying if PQ is a focal chord, I know they didn't tell you what to do, but there's nothing else you can do with it. Hopefully they'll say find the equation of PQ and show that PQ is -1. They'd have to give some guidance, all right? So if we say find the equation of PQ and show that PQ is -1, then, well, look at R and U at the moment. I can't tell whether they're the same or not unless I work out PQ. See how that's A bracket P plus Q? And this is -APQ P plus Q? Well, when we worked out that PQ was -1 and I put it in there for PQ, I got -A times -1 is positive A bracket P plus Q, which is the same as that. Yeah, we have to find, look, it didn't tell us how to do it, but it just said that PQ is a focal chord. So what you do, you work out the equation of PQ, that's the only thing you can do, and substitute the focus into the chord. And that's when they say something's a focal chord, that's what you do. You find its equation and substitute the coordinates of the focus. When it says PQ is a focal chord, they're telling you that PQ passes through the focus. So what you do, you find the equation of PQ and substitute the focus into it. And that gives you the result PQ is -1. Then you can work with that and put it in there. Look, these are hard, girls. They're hard. Finish that question because we've said if RU is parallel to the axis of the parabola, it is a vertical line. Thus, or then, the x values of R and U must be the same. So we can say, well, now R and U lie on a vertical line. Reason, x coordinates or ordinates, x coordinates are the same. We done? Because they've got the same x values, they must lie in a vertical line. How do you think of it? You think of it if you had points such as 2, 5 and 2, -1. Girls? Yep. Do you get that now? All right. So R and U lie on a vertical line. X coordinates are the same. Are same. Do you get it? A bit hard, girls. We need to find the equation of the tangent at P. You will find the gradient of the tangent at P and point gradient formula. Now, there are two ways we can find the gradient of the tangent. You can either start with x equals 2AP, y equals AP squared, and do dy dx is dy dp times dp dx, or we start with the Cartesian equation, x squared is 4ay, and differentiate that. All right, now I'm going to do that. Remember I tried to do it in question 13 and lost everyone? So x squared is 4ay. The thing is you still need to know how to do it in case you're left with no option. So girls, to differentiate that, it needs to be y has to be the subject. Y is what? Squared over 4a. So girls, 4a is just a constant, so just keep it there. Just because it's on the bottom, you don't treat it any differently. Whoa. So we've got dy dx is, just differentiate the x squared and just keep the rest in its place. There is no function down the bottom. There is no x. Do not use quotient rule. 4a is a constant. All right? It's just like 1 over 4a. It's just a constant. You just differentiate the x bit. What do you get? 2x over 4a, which is x over 2a. Now, that's the derivative, the gradient function. At the point where x is 2ap, see, I want the gradient at p. Don't I just substitute the x value at p into that? dy dx, now this all of a sudden looks easier, is what? 2ap over 2a, which is p. Now, you would have got the same thing if you started. Look, if I tend to be given the formula, I do it this way. If you're not given that formula, x squared is 4ay, and you're just given these, I do it that other way. dy dx is dy dp times dp dx. Got it? Depends on how you've been given the question. You can use this format all the time if you want here. Look, you know, if you've got x is 2ap, y equals ap squared, you know it's x squared is 4ay. You can just choose to do this every time. I don't mind either way. All right? The only thing with this one is you'll have to substitute the x value. Now what do I do? That's the gradient of the tangent at P. So this is the gradient at P. What do I do now? So equation of tangent at P, always point gradient. Y minus y1 equals m, x minus x1. You know what you're doing? Y minus, P is the point 2AP, AP squared. Y minus, come on, AP squared equals P is the gradient, x minus 2AP, great, no fractions. Y minus AP squared is px minus 2AP squared. So let's just take that minus AP squared over to the other side. Px minus 2AP squared plus AP squared, which is px minus AP squared. Because minus 2 plus 1 is minus 1. So, but we're not finished. So you've just found the equation of that line. Find the point A. What do you know about point A? You know something about it. Either x is 0 or y is 0. So we go at point A, x is 0. So you substitute x is 0 into that. So sub x equals 0 into y equals px minus AP squared, and you will get y is what? What? Well, it's 0, that's what you get, minus AP squared, which is just minus AP squared. So what are the coordinates of A? 0 minus AP squared. Great. We okay with this? Girls, this is so much about just finding, all you're doing is finding equations of chords or equations of tangents, and then you're substituting points in. That's all you're doing until we get to the other gradients, a perpendicular stuff. But at the moment, that's all we're doing. See that? Find the coordinates of A. You've got to know something about A. You know that to get to A, it's 0 across, y units down. So that's x is 0. All right? So we've found the coordinates of A. Part B of the question says, find the equation. So girls, they just ask you the same thing. Find the equation of either the chord, the tangent at P, or the normal at P. And then they might ask you for Q as well, which is done the same way. So find the equation of, so down here. So find the equation of the normal at P and find point B and point B, which is where the normal intersects the y-axis. Now, I'm just going to come back up. So find the equation of the normal at P and find point B, which is where the normal meets the y-axis. Okay, so, yep, don't let them in. All right. Okay, so, can I go back up to my diagram for a minute? Hello. Find the equation of the normal at P. Well, that's the tangent at P, the black line. The normal at P goes like that. It's at right angles. And it says point B, where the normal meets the y-axis. Are we okay? So B, normal at P is the red line. Tangent at P is the black line. We just found the equation of the tangent at P. We found the coordinates of point A. We're going to now find the equation of the normal at P, and we're going to find the coordinates of point B. Now, B has coordinates, what? You know one of them? 0 something. Oh, no. That's the focus. All right, good. A, 0 question mark. I'll just leave it. All right, let's find the equation of the normal at P. I'll just do a little sketch. Here's the tangent at P. Girls, you don't have to start from scratch. Looking back up at question part A, let's see what the gradient of the tangent at P is. Look back up at your notes. Gradient of the tangent at P is P, so you don't have to do it all again. You've already done it. So therefore, the gradient of the normal at P is, flip that, -1 on P. So therefore, the equation of the normal at P. As I was saying, 100% of the time, point gradient formula with this topic to find the equation of a line. Y minus y1 equals mx minus x1. P happens to be 2AP, AP squared. All right, let's go. Y minus AP squared equals negative 1 over P, x minus 2AP. Let's get this P out of here. So times the P on the other side. P bracket Y minus AP squared is negative 1. So I'm going to cover the P because it's gone. I get negative X. You okay, or can I expand? Plus 2AP. So I took the P over and then I did negative 1 times each of those. All right? Now let's expand. PY minus AP cubed is negative X plus 2AP. Now listen, with this topic you can't make algebraic errors because you end up in the biggest mess if you do. Your questions will never work. So just be really careful and take your time with it. Okay, that's the equation of the normal at P. I don't mind what we do. Let's make P the subject, PY the subject. So PY is negative X plus 2AP plus AP cubed. Now, we want to find the coordinates of B. So, to find B, you sub X equals 0 into that. Can you see why I took everything over the other side now? So you get PY is 0 plus 2AP plus AP cubed. And the 0's gone. So isn't Y just? That's gone. It's 2AP plus AP cubed over P, which is 2A plus... All right, that's cubed, yeah, because you know why I wrote it, because someone gave me the answer. So it's 2A plus AP squared. So that's what B is. So B is 0, 2A plus AP squared. Anyone got, that's just, can't read it. So therefore the point B is 0, 2A plus AP squared. Now you may see it written like this, 0, A bracket. Do you know what I mean? A is a common factor, 2 plus P squared. You might see it written like that instead. Instead of 2A plus AP squared, you might see it written as A bracket 2 plus P squared. All right, so it's written like that, so you don't need that. All right, but, you know, both answers are correct? No, of course not. Now, so we've done part B. Now for part C. Jeez. Girls, these are as hard as you're going to get. So earlier questions in the exercise will just say find the equation of the tangent, find the equation of the normal, show where it cuts. You should be able to do that. But it's always this part C bit that's going to be the trickiest bit. This is the interpretation now. The others are routine. Find the equation of the chord, routine. Equation of tangent, routine. Equation of normal, routine. You'll see it over and over again. But girls, where does the tangent and the normal cross? Well, no. Where does the tangent meet the axis? That's fairly routine. Where does the normal meet the axis? That's fairly routine. Now for part C, girls. C, if S is the focus, it's there, 0A. C is the foot of the perpendicular at P or of P? No. C is the foot of the perpendicular, now I'm reading it, from P, that's better, to the axis of the parabola. Now I know what it is, from P to the axis of the parabola.
So straight down.
The foot of the perpendicular from P, no, the axis of the parabola is that. Is it? All right, P's here. There's P. It's the, P is the perpendicular. No, C, sorry, is the foot of the perpendicular from P to the axis. Well, it's not this. That's the normal. C is this. The foot of the perpendicular line drawn from P to the axis of the parabola. It's that. Definitely that.
So if we can't even find where
And S is down here. Actually, girls, can I have liquid paper, please? No, we can. Foot of so the perpendicular from P to the axis is you have to draw a line from P to the axis, and that line needs to be perpendicular to the axis.
0 AP squared.
And C is the bottom of that perpendicular line. So C, girls, if the coordinates of P are 2AP AP squared, tell me what the coordinates, C is 0 across AP squared. So C is 0 across AP squared up. So you already know the coordinates of C. S is 0A. We know the coordinates of A, which are going back 0 minus AP squared. We know the coordinates of B, which are 0, 0, 2A plus AP squared. Now, girls, all they're asking is for the distance. So I'm going to write down all the points here. A is 0 minus AP squared. B is 0, 2A plus AP squared. No, you don't need it. When they're up and down, girls, if I had, this is 5 and that's 3, would you tell me, Miss, I'm going to use the distance formula? You're going to say it's 2. Right, so, girls, save some time. 0 AP squared. So isn't it just the y values minus each other? So I want distance AS. Now, AS are above each other. Now, be careful. You always do the top point minus the bottom one. So, distance AS, here's S, 0A. So, down AS, which is the y value of S minus the y value of A. So, always do the top point minus the bottom one, and you'll get A minus AP squared, which is A plus AP squared. SB, you do the y value for B minus the y value for S, because B is higher up than S, and you would get 2A plus AP minus A, and you get A plus AP squared, therefore AS equals SB. Next bit, work out CB. Now,
Just write CB equals 2A, not 2 alpha.
all right, so show that CB equals 2A. Well, what's CB? The y value for B minus the y value for A.
2A plus AP squared.
Yep, minus AP squared, which is 2A. So therefore, we've done that. Girls, I just told them to be quiet. And part 3, we're done. CB is 2A. Part 3, find AO. Well, girls, this is like directrix. Like, if this is 0 minus AP squared, what's that distance? Well, isn't that 0, 0? So just subtract the y values. 0 minus negative AP squared. Girls, it's like this. Watch. If this is the point -2 here, what's this distance? How many units? 2 units. So this is the point negative AP squared. So the distance is 0 minus negative AP squared, which is AP squared. 2 is whatever C's y value is minus whatever Y's, the origin's y value is. What is it? AP squared minus 0, which is AP squared. So we're done. Therefore, AO equals CO. So, girls, no distance formula involved at all. O's the origin. O is always the origin. So because, like O's the origin, girls. So if C is, like let's say C was up here at 3, that's 3 units. But C is up here at AP squared, so it's AP squared units. Okay? Now, I'm still going to be doing question 12, 15. You can go and try and do them on your own, or I can do 12 now and you can stay and watch. So if you want to stay and watch, fine, I'll do 12, or I might do one of the harder ones. Let me just think.